Okay, so we're going to be reviewing a skill that you guys learned in Algebra 2, but is going to be really essential for what we're going to start doing moving on to some other things. So what we want to do is we want to simplify, multiply, or divide rational expressions. And the main key thing here is that we really think about canceling out common factors. So we want to factor and we want to cancel out common factors. So there's just some common errors that I want to make you guys aware of. So some common things I see you guys doing on like your weekly reviews is that you guys get something like this and you guys want to cancel out the x's. So those x's are not factors. When I look at this expression, a factor is something that is only using multiplication with other factors in the problem. So x is a factor. Down here, x is not a factor. X is a term because it's being added with 2, and the x plus 2 altogether is a factor. So this x cannot cancel with this x because this one is a factor, and if there is a like one, it could cancel, but this x is not a factor. It is one term in a larger factor called x plus 2. So I want to compare that to if you had something written like this. Here, when we look at this, the numerator, that's the top of the fraction, has one factor, x. The denominator has 2. X is one factor, multiplying this other factor of x plus 2. Now this x can cancel this x because they are common factors in numerator and denominator. It still cannot cancel with this x here because this x is a term. It's not its own factor. So our goal is going to be to factor things and then cancel factors. So when I look at part A, I want to factor, and I want to remind you guys when you're factoring to really look first for the GCF. So when I look at this numerator right here, the GCF there is x. Both these terms have x in common. So x can become one factor on its own. And when I factor x out of 2x squared, I'm left with 2x. And when I factor x out of x, I'm left with 1. So now the numerator has been written in a way that it has two factors that are multiplying it, one factor of x and one factor of 2x plus 1. In the denominator, you see it already written in a way where it has two factors. One of these cannot be factored any further, so x plus 1 is completely factored. That's as simple as that factor will get. However, x squared minus 4 is factorable. So that should be one of those difference of squares that we should remember that factors as x minus 2 times x plus 2. So now when I look at what I have here, I might be tempted to cancel stuff out, but in reality, none of these factors cancel. So I would either leave this as my solution or the original problem as it was written. There's nothing here to cancel out and make it simpler. All right, looking at part B, again, I want to start with the greatest common factor. In this numerator, 3, 6, and 24 are all divisible by 3. So I want to create a factor of 3 and write what's left when I factor out that 3. So 3x squared when divided by 3 would leave x squared. 6x when divided by 3 would leave 2x. And minus 24 when divided by 3 would leave minus 8. There is no greatest common factor in the denominator. So the way I'm viewing it right now, I now have my numerator written in a form of two factors, the 3 and then this quadratic here. And my denominator is technically still written in a way where there's only one factor, this right here. Okay? However, I'm going to check to see if this and this are factorable because they are written in a quadratic form. Sometimes those are factorable, and if they are, I'm going to break them down even further to see if anything cancels. So when I look at x squared plus 2x minus 8, and for those of you that struggle with the factoring a little bit, if you guys remember, you did stuff like said, the a value here is 1, the c value is negative 8, 1 times negative 8 is negative 8, and then in the middle I'm trying to make a 2. So are there two values that multiply to make negative 8 and add to make 2? And so we would say something like 4 and 2, where the 2 is negative and the 4 is positive. So that x squared plus 2x minus 8, we're really now going to think about as x squared minus 2x plus 4x minus 8, like this guy. 2 got replaced by a more complicated version of 2 with two parts. so that we could factor by grouping. So those two have x in common, leaving x minus 2. These two have a positive 4 in common, and it leaves x minus 2. So when we look at these two pieces, their common factor is x minus 2. When that gets factored out of this first piece, if you divided out the x minus 2, you'd be left with an x. And in the second piece, if you divided out the x minus 2, you'd be left with a plus 4. So x squared minus 2x plus 8 factors as x minus 2 times x plus 4. And if you do the same thing for x squared plus 4x plus 3, and if you struggle with factoring, you should pause the video, see if you can factor it correctly. You should get x plus 3 times x plus 1. Okay. And again, nothing here factors, so this would be the final answer. Okay. If we saw something that was more factorable, like we saw something like this was an x plus 3 and this is an x plus 3, then we could actually cancel them out. Okay. All right, so looking at part C. Part C is a little different because it's two fractions and they have division between them. But remember that fraction division is the same as fraction multiplication if you use the reciprocal of whatever you were dividing by. And that fraction multiplication just multiplies straight across the top and straight across the bottom. So basically, any factors in the numerator, in the top of the fraction, can cancel with any factors in the denominator. So I'm going to start with this 5a squared minus 20. If I factor out a 5, I would be left with a squared minus 4. 2a plus 2 also has a greatest common factor. If I factor out a 2, I'm left with a plus 1. And then I have 4 and a. And then 10a minus 20 has a greatest common factor of 10. So here, I want to look and see if anything is can still continue to be factored. And this a squared minus 4 can continue to be factored. So I'm going to go ahead, sorry about that, and I'm going to factor the a squared minus 4 as a minus 2 and a plus 2. Sorry if you can hear my little one crying in the background. He's upset at what they took from him. And if you can't, well, that's good. All right, now when we look at this, we can see that there is this common factor of a minus 2 in the denominator and in the numerator. And so that entire factor of a minus 2 can cancel out. Then in the denominator, we have a factor of 2. And then in the numerator, we have a 4, but 4 contains two factors of 2. So you can cancel out a 2 as long as you cancel out a 2 out of something in the numerator, which would be 4, and it would still have one other factor of 2 left. And the same kind of idea can happen here with the 5 and a 10. I can cancel out a factor of 5. When I cancel a factor of 5 out of 10, I'm left with 2. So keep track of what you have left. In the numerator, we have left a factor of a plus 2, a factor of 2, and a factor of a. And in the denominator, a factor of a plus 1 and a factor of 2. So I have a 2, an a, and an a plus 2 in the numerator. It doesn't matter the order that I write them in because multiplication can be done in any order. And then in the denominator, I have a factor of 2 and an a plus 1. And now I see that I have both factors of 2 here that can actually cancel each other out as well. So then I will be left with a times a plus 2 over a plus 1. You can choose to distribute this a and a plus 2 if you want to, but you don't have to. You can leave it in this format, so I'm just going to leave it like this. Okay, so your goal here when we are simplifying, multiplying, and dividing is to take things and factor them and find out if factors can cancel. Just make sure you're only canceling factors. That's going to be our focus.